This lesson will be on interpreting a confidence interval using a t-distribution. Typically, a t-distribution is used when the sample size is less than or equal to 30 and the population standard deviation is not known. The formula that we use for finding a confidence interval for the population mean is x bar, and change colors here. Okay, x bar is the sample mean. T is the critical value. S is the sample standard deviation. N is the sample size. And those are the parts that you're going to need to find your confidence interval. So the first example we have is a random sample of 20 softballs is taken with a sample mean of 4.7825 inches and a sample standard deviation of 0.0639. We would like to find a 90% confidence interval for the true mean. So we want to think, if we want to find a 90% confidence interval for the true mean, the 90% will fall in the middle. That'll leave 5% to the right and 5% to the left. We're going to use the inverse t function on the calculator. So the area to the left right here will be 95. And remember, the t-distribution is based on the degrees of freedom. So if there are 20 in our sample size, our degrees of freedom will be 19. And when we use our calculator, we end up with a value of 1.725. So that's going to be our critical value. And actually, that value is here in the positive form, and it is here in the negative form. And our mean would be right in the middle. That's what we're trying to get a confidence interval about. So, the parts that we know now is we know our t critical value is 1.725. We also know that our x bar, which is our sample mean, is 4.7825 inches. Okay, we know that our sample standard deviation is 0.0639. Alright, and I believe that we can now find what our confidence interval would be. And I just realized I got a step ahead of the game, didn't I? Okay, the thing that we needed was the t critical, and we got that to be, let's write it out again, 0.95, 19 degrees of freedom, and that gave us 1.725. Alright, so we set it up to find our confidence interval, and we do 4.7825 plus the t critical times the standard deviation divided by the square root of the sample size, and on the lower end of that scale we end up with 4.758, and on the upper end we get 4.807. So that is our 90% confidence interval for the true mean of the population of the softballs. Now, what does this mean? What does a 90% confidence level mean? Okay, this is the percentage of all possible samples of size n, which in our case is 20, whose confidence intervals contain what we're trying to find, which is the true mu. When taking many samples, 90% will represent the population and 10% won't. It is correct to say that a range of likely values for the population mean is between 4.758 to 4.807 with a confidence level of 90%. It is incorrect to say, and this is where people get confused in how to interpret a confidence interval, it is incorrect to say that I am 90% confident that the population mean is between 4.758 and 4.807. It is all about the sampling process and not about an individual sample.